Hello and welcome to another great episode of Clean Code. I'm me, you are you, and today we're going to be tackling the daily top merchants problem from DoorDash. This is a pretty solid problem, and I think it's a really good benchmark to understand where you're at in terms of your Pythonic skill. This is one of those problems, if you can read the problem statement and you know what to do, you're over halfway there. You should feel great about yourself, right? 2/3 of it is just understanding what tools and abilities you can bring to a problem solution. That being said, let's go ahead and read the problem. We have been asked to find the top 3 merchants for each day in the data set, and we're quantifying the top 3 by the highest number of orders on that day. In the event of a tie, multiple merchants may share the same spot. Ties are totally cool, but each day at least one merchant must be in first, second, and third place. We need to have the output in year, month, day format. We also have to have the name of the merchant, and their place in the daily ranking. So we get 2 data frames, order details of merchant, and they're expecting a data frame as the output with the aforementioned 3 criteria. We go ahead and take a quick peek at our data. We see order timestamp is in a date time format, number of items, total amount earned. Looks like order details will be doing the majority of our legwork, but that merchant details has the name. So we are going to be having to do a merge. We're going to have to grab that detail. Just coming around, taking a peek at our data, seeing what kind of format we're in. So we see order timestamp is in, looks like year, month, day, but then we also have hour code. Looks like number of items is just an init, and we can check that right here, making sure everything looks good. Generally, for the most part, on Scratch, I don't see many instances where the data is different than the records would indicate, but it's always something to check when you're doing these interviews. Mistakes do happen, and it might just be a detail they're looking to see if you can pick up on. Okay, I feel like we have a really good handle on what this problem is trying to get us to do and how we're going to want to do it. Let's go ahead and jump into our notebook and see if we can't code up a solution. All right. Now, as part of our patented, tech interview process, we're going to go ahead with the yellow marker and we're going to highlight the key phrases we need to make sure we are solving for. So top 3 merchants, and then we need highest number of orders in that day. We can have a tie, so we'll just highlight tie. And then at least one merchant must be in first, second, and third place. There is a specific format for our answer, so we're going to highlight, that particular location right there, so that we can just quickly, when we see our final solution, when we're done writing our problem plan, we can go ahead and solve that. Looking at our data, we are going to also in green, going to highlight the fact that we need the name, we're going to need the order number of items, and we're going to need the order timestamp. Okay, now that we understand what key components of data we need to be using, let's make sure we have our problem plan in place. So the first thing that we're going to have to do is convert our time column. Second, we are going to need to do our aggregation step. Third, we're going to need to do our ranking, and then we're going to want to filter. Fourth, and then finally, we're going to want to merge to our final DF. Now, a lot of people have told me, hey, the problem plan doesn't really seem that complex. And problem plans are not meant to be complex. What they're meant to do is give you a quick frame of reference of how you're blocking out solving your problem. And this is going to be important when you work a full-time job in data in some place and you're starting to do documentation, right? You don't want to have to go through, 700 lines of code and have to figure out what are the blocking, like what's happening where and why. That is a really long, tedious process. It's something I've actually just done in my role today. What you want to be able to do is understand, hey, first we're going to convert the time column, then we're going to aggregate all of our stuff together, then we're going to do our ranking, and then we're going to do our filter, and then we're going to merge to the final DF. This also allows you to just kind of at a very high level intuitively think about the complexity of your solution. For example, you could do these steps out of order, but does it make sense to do that? Python, not so much, but if you use a language like PySpark, which we have a video out of how to solve this problem in PySpark, that does matter. You can create really, really inefficient code. And that generally means someone has to go back and make it efficient, which just slows everything down. It's better to measure twice, cut once, make sure you have a really good solution that's not necessarily optimized, but at least more optimal than doing it in a roundabout way. That being said, this is our problem plan. Let's go ahead and write out the functions we can use. And that will also provide you with an ability to look at the gaps in your knowledge and where you can do to improve as somebody working in data. Okay, so the way that I like to do this is to just look at your problem plan and then figure out what function am I going to use to solve. This is a really good idea. If you don't necessarily know exactly how you're going to solve something, you can figure out what you do know and then go look up what you don't. So we're going to need to use toDateTime. That is a pandas function, and then part of that's also going to be dt.date because we're going to want to format it and get rid of the time part of the date time. We're going to want to get rid of the time part. We just want the date. We are also going to be using a group by for our aggregation. We're also going to be probably using a size to make sure we're doing things in getting the correct number of occurrences, I think is the right way to say it. We're also going to be using a rank for our ranking. And then we need to use a pd.merge to combine our data frames to get everything the right way we want it. And then finally, we may or may not use this. I haven't coded the solution yet. So I think a reset index is going to make sense because we're doing grouping and then ranking and then filtering. Odds are pretty good that we're going to want to reset the index to make sure that we get a consistent solution throughout. So now that we know what we're being asked to do, and we know what data we want to use, and we understand the steps we're going to take to solve it, and we understand the functions we're going to be using, let's go ahead and jump back in the problem set and see if we can't code up a solution. Okay, let's go ahead and code up a solution. We're going to import pandas as PD as per usual, and then we're just going to follow our project plan. So our first step is going to be getting that order timestamps from our order details data frame into a dt.date. That's going to remove the time aspect, but keep the date aspect. So we get to keep the part I've highlighted here in blue and not this part right here, which is not helpful for our rankings because we're not ranking on an hourly or minute or second basis. We're ranking on a date. So that being said, let's go ahead now and do our second part, which is going to be our group by, and we're going to be using the order details data frame again. We're going to be grouping by our order timestamp, which we've just edited, the merchant ID, and then taking from the merchant ID, we want the size and we want to reset the index. Now, what are we calling for size? Well, we want to reset the index on order count. So this is going to put it in top down, so largest to smallest based on order count. It's a really great way to kind of get things ordered in the correct way. Next, what we want to do is we're going to use a group by again to get everything sorted out. So we're going to set a new column, merchant count, order rank, and then using the order details, we are going to group by the order timestamp. And we're going to use a dense ranking method, and we're going to do ascending is false. So it's in descending order, biggest to smallest. Now we had to do the grouping in 2 steps, but I think it is a nice clean solution. Next, we need to do our ranking. And luckily with the rank feature, it's pretty easy. So order details equals order details dot, and then we're going to set this new column we have just created, and we're going to say, hey, take only the top 3. And this is already grouped by date, and we've already done a ranking we've already organized it in descending order based on the timestamp. That's how that code works. It goes 1, 2. Now we just need to make sure that we can pull in the merchant name. So let's go ahead and do that with a PD merge. We're going to make a new data frame. And then finally, we want to make sure we're returning the correct data frame based on our coding solution. So here we go. We now have the order timestamp, name, and merchant order rank. Go ahead and click run code. Everything is running nicely. And we'll go ahead and check our solution. And everything is green. And the real cool thing about this particular solution is it's super fast. Now, part of that is because the actual data is not that large, but even if we were to expand the data, we're doing a pretty good job of, at every single step, kind of not reshuffling, but reorganizing our dense data to make the next step a little bit easier. You could do this all in one step, but it would be a very large step if you think about it that way. All right, on behalf of Clean Code, I have been me, you have been you, and we are so very grateful you took the time to listen to us today. Feel free to go ahead and watch another video if you'd like. Otherwise, we will see you next time.